So I'll leave that running and I'll turn off this blur. All right, so now hopefully that should be recording. I'll share my screen. I'll share my whole desktop. And my window is too big to see where the button is. There we go. See, this is what happens when you zoom in too much. And then this happens. Okay, so now that should be recording. All right, sorry about that. So now we'll have a record of what's going on here. So here's my general outline for the presentation I'm going to do. I hope it's not going to be too long. You can see up there, not too many slides, I hope. I'm going to go over asynchronous programming, the general concept of it. Then I'm going to look at a few examples in JavaScript, Rust, and I didn't put it up here, but C#. So I'm just going to brush over that because asynchronous programming is a broader topic that covers across many different languages. So whichever one you like, you'll probably be able to find aspects of this at play there. So first off, I'll show you a quick little example. A lot of modern web APIs that, frameworks like React use, they're all already asynchronous. This is because the computer has to handle the user input on the web page along with whatever code you're running. So I don't know if you're familiar, anyone who's used JavaScript before, here's a function called fetch, and it returns an asynchronous promise, which we can resolve using await. So this is a key term that we'll use in JavaScript a lot. The question is, of course, like, why would we design APIs around this kind of asynchronous thing? And why do we need to have this keyword that just kind of make things more complicated? For people who are new to asynchronous programming, it can almost seem like more overhead. But the fact is that a lot of operations on computers are not actually bound by CPU speed. In earlier computers, a lot of time is spent waiting on other devices, on input, output, on files being read on hard disks, trying to figure out, well, trying to wait for those operations to complete. So the idea with asynchronous programming is to abstract this waiting away so that we can organize our computation and actually spend more time computing. So here's a CPU usage graph from one of the servers I maintain. You can see here that a lot of the time on the CPU is spent on user and system tasks. And you see only a little bit of the CPU usage is spent waiting. So this waiting is usually waiting for like hard disk readings or network, whatnot. And then the rest of this is just idle time where the CPU is actually doing nothing. So this is from a Linux system. As we know, Linux is very mature at this point. It's what we call a preemptive multitasking operating system. Does anyone know what those two words mean? What it means is that the Linux kernel can stop applications and immediately switch context to another one. This is very important because when an application reads to a file, while it's waiting for a response from the hard drive, it can run another program. And this is what all modern operating systems like Windows, Mac, Linux all do in the background for you. Early versions of Mac OS from like the old Macintosh days in the 80s could actually only run one program at a time. And that was called collaborative multitasking because each application had to manually coordinate with the others. So this is one example of asynchronous computing, an example done on all of our computers. So now we get into understanding how it works. In JavaScript and a few other languages, we have this basic concept called an event loop. The idea is that JavaScript runs on only a single thread on a single CPU. There are ways to do multi-threading, which I won't get into here. But the idea is, how can we have out-of-order operations when we only have a single unit of runtime? What we do is we have an event loop. So JavaScript is structured around this cycle. The computer will wait for messages. This could be interaction. Then it will dispatch that message to whatever method is listening to it. So whichever function is listening for that event, then the method has complete control over the running. And after the method is done, it will return control back to the event loop. So in JavaScript, usually that means when you click a button, that sends a message to the event loop. That method is executed. The important part is that during this method run, nothing else can happen. So older web pages that use what we call synchronous APIs, in-order APIs, they might hang when you interact with their JavaScript functions. This is because their methods have taken complete control over the web page. So now, of course, we have asynchronous APIs and runtimes, and a lot of that interaction is hidden away. So whenever you click a button, it all happens in the background, and the event loop is synchronized in all these events. So now I'm going to reveal to you one of my favorite magic spells in all of computing. These are called higher order functions. So I want you to take a moment and stop thinking about functions as being different from data. Functions are, in fact, just special types of data that you're able to execute. Have any of you taken CS 240 when you've done MIPS programming? Knows on that? Yeah. So for those of us who have done MIPS programming, you understand that the data and the machine instructions are the exact same. Functions are data, and in fact, in JavaScript, they are even objects with properties. So who here has taken like Java, object-oriented programming? Who knows a little bit about that, right? So we're all familiar with how objects have properties, right? They have public methods, private methods, they have properties. JavaScript takes that a level further in that literally everything is an object and you can take properties of it. So I'll show you here in JavaScript, the function used to output to the screen is console.log. So in a terminal or in the dev console of your web browser, you can type out console.log and then you can get properties of that. You can do .name or even toString. So we've probably seen variants of toString in Java, takes an object and converts it to a string. So let me show you what that looks like here. So here I have console.log. I can execute it to print something out. And then we just get hello and then undefined, which is just because I ran a function. If I do console.log.name, we get the name of the function, which is just log. That's because console.log, that's the name of the method on the console object. I can also do toString. I don't know if it'll do much here. So this is the actual code that Dino uses for console.log. So in JavaScript, you can actually just get the whole body of a function just by doing that. If I run this in Chrome, which uses a different JavaScript runtime, if I do console.log.name, again, we get log. If I do toString, we get this, which says native code. So they've optimized this function to the point where it can't even be expressed as JavaScript code. Functions have other properties in JavaScript too. We can find that out using tab. Oh, well, I guess it doesn't show it. But there are a few other properties. I think you can do .call. This is another method. It actually runs the function. This is important in JavaScript for other reasons I won't get into. There are a lot of shenanigans you can do with this. If you're really curious, I would recommend looking at advanced JavaScript because although JavaScript is known for like the web, it has a lot of advanced features that actually make it a lot like Lua and other languages. So naturally, if functions are just data, we can pass them as parameters and return them as values. So here's a quick example I made up. This function returns a function. So here I have the keyword function. This is how you define a new method in JavaScript. I have the name. I give it a parameter. In JavaScript, we don't have such thing as types. Well, we do have types. You don't need to declare them. JavaScript just figures things out. Then here I'm returning another function. This is a concise version of a function. This is also called the lambda function. Has anyone heard that term before? Lambda function. I think for Python users, they just use the keyword lambda. So anyways, this is the same thing as putting function. I'll show you how this works. What I do here is I make a new variable. We can call this a constant variable. I do create adder 2. And then now I can run that function, even though this is also a variable. This, you can also do this in C++ and in a bunch of other languages. You can make functions and then pass them around as values. This is an incredibly important concept in functional programming. I can't stress how fun it is to try to solve problems using higher order functions. It makes things like this huge, like, it's really fun. Trust me, if you get to that point, try it out. Let me show you an example here. I'll run it in my Dino so you can see what that looks like. See here, I'm going to define my function. I'll call it create adder. I'll give it the number. what am I going to do here? I'm going to return a new function. It's going to take a number x, and it's going to add n to that. So there I made my function. I can see here, create, oops, I just filled it in on accident. Create adder. Through that, here's a function. I can do the same things here. I can get its name. I can get its body. However, what I'm going to do now is I'm going to make a new variable. We can also use var in JavaScript, so I'll just use var. This function is going to be called add2. And it's going to be the return value when I create an adder with the to parameter. Add2 is now a function. You see here it's called anonymous because we never technically gave it a name, even though this is a variable name. Again, functions are objects, and in this case, this one has not been named, even though we put it in a variable. Remember, we can have one value in multiple different variables. If I now run this function, it'll add 2 to whatever number I give it. So when I'll add 5 plus 2 is 7. 5 plus 10 is 12, or 10 plus 2 is 12. And I can make any sort of other adders I want to. Now I have a template for functions. Now if I run add 5, it'll add 5 to any number I give it. Are we following here, like how this kind of works? This is an incredibly powerful tool. It's really fun. Have any of you heard of map reduce for arrays? Heard of that term yet? This is another very fun thing when it comes to solving problems. We can take a list and we're going to map it with the add2 function. This is going to return a new array where every number has had the function run with it. So I took this list, I told it, run add2 on every single one of these numbers. And it did it. And now we have 3, 4, 5, 6, 7. Lots of cool things you can do with it. This function doesn't even have to return a number. It could return a string, another object. So many powerful things you can do with this. I can't stress how fun this is to work with. Okay, here's that little example. So the reason why I wanted you to understand a little bit about higher order programming is because in JavaScript, we have this abstraction for asynchronous programming that we call a promise. So who can guess what a promise is? Who wants to raise their hand and just tell me? How'd you know that? So yes, a promise is just that. It's a pinky promise saying, I swear that I will complete this operation for you at some point in the future, pinky promise. That's literally all it is. So a promise can be in progress or it can be fulfilled or rejected. So fulfilled means it has a value, the operation completed successfully. And rejected means that there was an error in the process somewhere. So here I'm going to show you a little example of how we use promises. So we're going to make a new promise. This type of syntax will be familiar for those of you coming from Java. But in this time, the constructor takes a parameter of a function. So just like I said, functions are data. We can pass them around. It gets 2 parameters called resolve and reject. Anyone guess what these 2 are? What type they are? Take a wild guess. Are they a number? Are they a string? Or are they another magical type of data? They're not Booleans. They are actually functions. So now we're getting like knee deep in the wood, turtles upon turtles, right? We have a function that we gave it a function whose parameters are functions. So stay with me here. This is not as complicated as it really does seem. This is basically the operation we're going to complete in the future. So next we use this thing called set timeout. So can anyone guess what set timeout does? So you're close. What this does is in 300 milliseconds, it'll run this code. So you see here in 300 milliseconds, this will resolve. I'm actually not using reject here because this function's always gonna turn true. What I could do maybe I'll use a random number here maybe on 50% of the times it'll reject just to do something, but I won't do that. Here, it just resolves in 300 milliseconds.
You supply a reject.
No, actually, you could just put resolve. If you knew your thing wasn't going to have an error, which is rare.
Why is it second?
Um, a lot of timing things use milliseconds. I'm not exactly sure why. I think it's because milliseconds can be in integers, but then if you get to seconds, you have to use floating point, and then it wouldn't be as accurate. That's my guess, at least. You have to ask the JavaScript designers why they chose milliseconds. I know some like C APIs even use like nanoseconds or something insane like that. What we're using here is part of the abstraction of what promises lets us do. So once I have my promise, I can schedule something to happen when that promise has finished. So it's basically saying here is then console log, then handle the promise. You can chain these, and that's another important concept. So what's going to happen is in 300 milliseconds, my promise is going to resolve. It will console log, and then it will run this function handle promise. And then if there's some error, it'll use console error to print that. Of course, this doesn't really matter because our promise will never have an error. But if it were to, it would catch the error. So who's heard of try catch before, right? So this is how we do try catch using promises. Then catch. I'll show you this example in my JavaScript here. Oops, wrong one. So here I'm going to make a promise. And what I'm going to do is I'm going to make this promise resolve in like 10 seconds so we can just see how it works. We like using res sometimes to shorten it. I'll use 20 seconds so I can talk and I can type out the other one too. Watch my parentheses. Okay, so when I do this, the timer is going to start, and then I'm going to do a dot then. So if I look at my promise, we see it's pending. So the value hasn't completed yet. I'm going to tell my computer, after my promise is done, I want you to log it. And you see it gives us another promise that's also pending. That's how we chain things. Dot then just returns a new promise with another piece of code tacked on top of it. I can take this see, it already resolved. There it is, and it printed out hello. So I ran out of time and I just printed it. So you can see that I returned that value hello by telling it to resolve. Resolve hello in 20 seconds. I told the computer, after my promise is done, then console log. And it did that value, it logged that string. I can do other things as well. I could tell it maybe I'll pass this off to another function. Maybe this is a user input. I can tell it now add 5 to it, whatever I want to. In fact, maybe I'll just do that. Make another promise. Instead, I'll tell it to resolve to the number 5. Oops. I need to set this to a variable. And I'll tell it when my promise is done, I want you to add 2, and then log the output. And that'll give us a new promise, and then I'll give him 20 seconds. This type of composability is very important for asynchronous programming. The idea is, so you now put out 7, that was 5 plus 2, and then output it to the screen. The idea is instead of directly telling the computer what order to do things in, we'll tell it how we want things to happen. So we should say this will happen after that, this will happen after that, and I don't care in between. So I was looking at the Microsoft documentation for how they use it in C#, and one example they used was when you're cooking. Usually when you're cooking, you put eggs to fry and you put the toaster, but you won't do those and wait for them to happen. You don't put the eggs in the pan and watch it. You start doing other things. You pour a glass of milk, you'll set the table. And that's the idea of asynchronous programming. Here. So, of course, unfortunately, dot then chain does get pretty messy. So that's when we have the async and await keywords. What it does is it just runs the dot then for you. When I do await my promise, it'll just wait for the value to come, and then it'll put it in console.log. So this is kind of a way, if you're just getting into asynchronous programming and you want to be able to use these functions without worrying too much about the whole promise shenanigan. So this, I hope, is very familiar to those of you who have known Java. You can really understand what this does if you just kind of ignore the await. Cool. Okay. There are times when we actually don't want to wait for the value. So other functions can manipulate promises, and we can even combine them together. So here, I'm not waiting for them to finish. I'm simply starting two operations. I'm going to get the SDSU website, and I'm going to get the acm.sdsu website. Now what I'm doing is I'm combining these into a new promise that will finish when both of those promises have finished. So you see why this is useful now. This is also what happens on your computer when you download two files. You don't want to download one file and then wait for the other one, or you don't want to download one file, wait for that one to be done, and then start downloading the other one. You want to download two things at the same time. This is how you might do it. That's why we don't want to put a wait there, because otherwise it won't start the other download. So now I'm going to talk a little bit about asynchronous API design and why this is pretty useful in more ways you might think. So Dino and Bun are two JavaScript runtimes that are both async first. What that means is their APIs are specifically designed around being used as promises and using await operations. There's no need to enter an async context. This is something that some languages have where you can only use await if you have an async function. In Dino and Bun, you're already in an async context. So I'll show you an example here. If I go to my, oh, it's over here, but I put it on the side. I can just use await here. And then here it is. I got some values here from Google. If I go to my web browser, though, and I go to here's JS Fiddle, this is a nice little website you can use to test out your JavaScript methods. If I try using an await fetch here, it will give me an error. Yeah, if I open this console, it'll work better. Yeah, see, it says right here, await is only valid in async functions and the top level bodies of modules. So we're moving towards in JavaScript world to having everything be async by default. So soon you won't have to worry about this when you're doing web development. Anyways, the basic idea is we want to make these IO operations non-blocking. This is another key term we like using in the async world. We want to design our APIs to not block as much as possible and let the user decide when you want to wait for things to finish. So again, here's a little screenshot I showed. Bun and Dino both have very optimized asynchronous APIs, and they regularly perform better than Node.js at server tasks. So if you're unfamiliar, Node.js, Dino, and Bun are all JavaScript runtimes that let you run JavaScript outside of the web browser. So people use these a lot to run web servers. Again, you can server-side render React. So this is something that me and Everett might want to look into. So you can have the React work faster. Yeah, they generally perform better. I don't know how Bun does it. I think they use a completely different runtime. Yes?
So a lot of for web design, right?
Yes, but these apply to a lot of different languages.
Apply that to web.
Yes, they also very apply to app development. For example, in iOS, iOS app development commonly uses Swift, right? And Swift also has similar asynchronous constructs. You'll see that actually a lot of languages like this idea of a promise because it's a very useful way to encapsulate that idea. So again, you use asynchronous design for user interface. You don't want to have your user clicks on something and then it completely freezes. You want it to click and then it shows a loading bar. and you'd use that by using async APIs. You wouldn't put an await, you would have the operation start, and then you check in on it. And then you would finally have the value at the end. So this is also very useful in app development. For desktop apps also, usually we would do something called running things in a background thread. I don't know if you've ever heard of that before, but this is useful for single threadedness. Does that answer your question? So yeah, new web APIs that Chrome likes to do and Google likes to make for their Chromebooks, they almost all use promises now. So you can open files, download web pages, fetch from APIs using REST. All of these are done asynchronous now. In ancient history, we had XML HTTP request. Internet Explorer first started this. Microsoft made an extension. I don't know if you know about that piece of history where they got sued because Internet Explorer was installed and everything, and they killed Netscape. Interesting history, but it was pretty hard to use because it was kind of the birth of asynchronous programming. So XHR, as we call it, it was asynchronous, but we didn't have promises at that time. So it's really complex to use. Anyways, this concept of a promise is very powerful. So who here has heard of REST? At least like heard of it, even if you haven't used it. So Rust has also been moving to implement more asynchronous features. I don't know, I put borrowed here, but this is kind of a generic concept. They called a promise a future, which is another way of saying it, right? The operation is going to happen sometime in the future, and that's why we call it futures. So here's a little link if you want to learn more about how Rust language implements async. I have a little example here that I copied from the Rust book. You see here that this is very similar to the example I did where I fetched two websites. So here, I'm not putting await. There is no await here, even though this is asynchronous. I'm telling to download two websites that I'm going to run both futures. And instead of using promise, instead of using promise.all, here Rust uses join. But I hope you understand that this general concept can be applied to a lot of different languages. So again, Swift has something like that for iOS app development. Java, I think Kotlin is what people like using now. In the Java world, Kotlin has abstractions for asynchronous programming. I'm going to show you another example in C#. C# calls them tasks. I don't know why they can't all just call them the same. But yeah, here's another example showing a different concept of asynchronous programming. So you can either wait for all of them to finish, or maybe you just want to wait for one to finish. Like you're racing two cars on a track. You only care about whichever one finishes first. So here I have a list of tasks. While I have tasks in the queue, I'm going to await when any of those tasks finish. I think in JavaScript, they call this promise.any. But you will find analogous methods that manipulate these sort of futures and promises and tasks. So here we get that finished task, we get the value, and we can say, oh, look, this task finished. We'll get rid of it from the queue, and then we'll keep looping. So that's a lot, but I hope you get the general idea that we can manipulate these types of futures values in a lot easier ways. Yeah. Anyways, that's almost all I had for you today. I just want to say that asynchronous programming is very important. You can make faster programs that schedule things that to run in parallel. I know I said that a lot of async operations are just run out of order, but Rust has runtimes where you can actually have asynchronous operations run in parallel, which is very important for speeding up your programs. Servers will be better at handling multiple requests. So again, like I showed in that image previously, Bun and Dino with their async APIs can handle a lot more requests at one time, because instead of waiting on one request, while they're waiting on one request, they can do other operations for the other ones. And it helps you break free from sequential programming and wrap your head around these operations in a different way, which is always useful to have different tools in your toolbox on how to handle different problems. If you want to explore more, try writing a web server in JavaScript. You can figure out for yourself using Dino or Bun, look at their documentation. You can try using threading, using Rust asynchronous methods. I know like Rust does threading. I haven't looked into it. I'm not a Rustation, as they call themselves. I do want to learn that at some point. I know Rust is kind of that up and coming thing. And if you have a favorite language of yourself, you can find asynchronous principles, and I'm sure you can work around some problems in your language of choice. And that's all I have for you today. Thank you so much. Thank you.
We still have a little bit of time left. I'd like to do a few announcements, maybe a few quick polls. So, first of all, thanks again to JP for this awesome presentation. This is a very interesting topic that I think not a lot of people get to learn about. So I'm glad that we all had this opportunity to learn about this together.
I actually don't know how to stop it.
What's that?
I have my meeting running now. I don't know how to stop it.
Oh.
I'll just do it. Oh, there it is.
Okay, so a lot of stuff was talked about today. Who can tell me something that they learned today that they had never learned about before?
Asynchronous programming.
Okay, more specific.
So I have like some experience with like multi-threading,
Yeah.
so being able to do asynchronous programming with a single CPU is pretty interesting. And you then you do that.
Yeah, exactly. I think that's the most interesting part of JavaScript because they have to work around that limitation. Yeah.
Yeah.
But these threadings also work in async. It's pretty cool. You can look at that.
Anyone else have something maybe back there anywhere? Something I learned today.
Come on, speak
Okay.
up.
Actually, does anyone have questions for JP? I know this was kind of a lot, kind of packed in a short amount of time. So, anyone?
You use this in like your course.
I'm using my coursework, but I use it in a lot of personal projects. So I use it like in web development and whatnot. I can use a weight.
Yeah. So this is definitely one of those skills where you might not cover it a lot in your courses. That's why it's so helpful to learn it now. So you can kind of be the one person applying for that job who knows how to do that thing, because this is really important. And I mean, I'm sure there's lots of applications.
Yes, there are a lot of other cases where you use this.
Yeah. So he mentioned JavaScript a lot today, and he also mentioned React a couple times or Node.js. So are any of you here, by show of hands, familiar with React.js? Okay, only a few of you. So React is a framework for developing website applications using a mix of JavaScript, HTML, and CSS. It's pretty highly in demand skill. Actually, I think JavaScript is currently the most widely used language in the industry. So would any of you guys be interested in having a workshop, kind of working through like building a personal portfolio website with React or something like that? You could like showcase your resume and all that. Yeah. Okay. So that'll definitely get somewhere on the agenda. Next week, we will not be meeting here. Instead, we will be having a big social event in the Aztec Student Union Courtyard. That's next Wednesday, 4 to 6 p.m. So it'll go a little longer. You don't have to be there the whole time or at all. It's kind of an optional event just to reach out with the university community. But there will be plenty of food. I know I've mentioned this in past meetings, but for those of you who weren't here, there's going to be lots of pizza, soda, what else do we have? Cookies?
Cookies.
Yeah, we have a lot of cookies too from Aztec Catering, which is really good. I don't know if any of you have had those before, but they're some of the best cookies ever. So if you want some really good cookies, drinks, pizza, and of course to socialize with other people and learn more about your peers who may be interested in the club, you can kind of be the more experienced members who have been here for a few weeks, and you can kind of tell them what the club's about if you feel like it. Of course, the officers will be there as well. So yeah, that'll just be a big fun, lighthearted event for just networking, eating good food. As I said, Student Union Courtyard, can't miss it. Big area right in the middle of everything. 4 p.m. next Wednesday. So hope to see you guys there. And then, was there anything else you wanted to cover?
I don't really have anything else I wanted to specifically cover.
Yeah, well, we have like 20 minutes left of the meeting. So I'll let you guys use this time to do whatever you want, kind of talk to each other. I know a lot of you weren't here on that first meeting when we had a big speed networking thing. So if you may want to turn people around you, introduce yourself, talk about something, meet someone you haven't met before, this is your time to be in a room full of people with similar interests. So yeah, go ahead.
Thank you so much, everyone.
Thanks again, David. That was really cool.
Thank you.
JP.